Welcome to my channel AI Basics with AK. Here we are with another new episode on Introduction to Statistics. This is our episode 4, which is data visualization for statistics. In the last episode, we have introduced on the descriptive statistics, which is mainly mean, mode, median, mode, standard variance, and standard deviation and variance. Here we will try to visualize those things using histograms, box plot, and scatter plots. Why this is much more needed? Because we need to understand the patterns within the data, right? So the patterns is not only observed by mean, median, mode, but also when we start visualizing the data. So visualizations are like windows to the data, right? This is the famous quote. I think most of you would know about it, that a picture is worth 1,000 data points, because it can communicate insights very clearly. Isn't it so? Now let's understand the history. What is a histogram? Histogram shows the distribution of one single data point. Data point, not a data point, but one for one variable. Here we are trying to see the distribution of exam scores. Now exam scores varies from 0 to say 100, right? Now somebody wants to visualize this data. Okay, what is a pattern around it? Mean, median, mode gives only one data point, like, because mean tells you, okay, the mean average score is about, say for example, 77. Mode will say maybe, okay, it is 78, and median might say it is 79, something like that, right? But however, none of these will give you the complete pattern around the data. But the pattern around the data is only provided by a histogram. Here you can see that, okay, here there are some data points, but there are some people which who scored between 60 and 70, and also there are few people who have scored above 95, and also there are very few people who have scored between 0 and 50. So here you could able to see the pattern of data. Instead of actually analyzing the entire data set, you could see that what's the underlying pattern within the exam scores. Now let's explore further with respect to the box plot. Box plot actually clubs both the histogram and median data into an intelligent plot. Okay, I think I'll come back to these explanations, which is median, interquartile, whiskers, and outliers, when I'll actually describe about the plot. And it is very grateful when we are actually comparing two different groups, especially when we have classes of two different classes like class A and class B, and we want to compare the distribution very quickly between both class A and class B. The box plot will be very helpful. I'll explain you how. Now you can see this is think ahead. Okay, this is like an lower end of a data point but higher end of a data point, but this is not the entire range. This is just whiskers. These are called whiskers of the box plot, and this is nothing but your box, and this box is not the complete range. This is called IQR, which is nothing but interquartile range. What does this box says is that what is an interquartile range? It ideally tells where is my maximum data is like because this is my centralmost 50% of the data set. Because what it tells is that, okay, what is my 25th percentile data and 75th percentile data. So this is my 50% of my data is within these boxes, and extend these whiskers, we can ideally call it as a range. But why these are called whiskers? Because this is this is calculated as a distance of 1.5 times of IQR. Why this is calculated 1.5 times of IQR? To identify any outliers that comes in after this range. Why, I will tell you if I go back to our histogram. Now here histogram, you can see that you can see the middlemost 50% of the data is here. So this most of the data lies in this middle 50%, right? Now say for example this entire range C60, say for example to 80, which is 20. Now you calculate this 20 as you calculate this 20 as your IQR. 1.5 times of IQR is nothing but 35. You minus 60 minus 35 becomes your lower end of your whisker, and 60 plus 35 becomes your higher end of your whisker. 60 plus 35 is almost 95. There is no outlier almost greater than 95 because the range is between 95 to 100, and 60 minus 35 is 25. Because and the range is between 0 to 50, so there is no outlier here. Any score which is less than 25 and any score greater than 95 is an extreme outliers for this possible data set, because we will know people who are actually failing and people who are extremely top. So that's immediately this box plot identifies, and exactly you can see here, okay, in class B you can see somebody has an outlier exactly as with single dot because he's an outlier. And also you can see that class B, the middlemost 50 percentile is actually larger than the class A. It means the class B performance is slightly better than a class A as a whole group. Isn't it so? So within this one graph, rather than seeing the whole data, we are able to just extract the meaningful information that class B, almost the middlemost data lies between say 75 to near 90, whereas class A is almost from 68 to almost near 80. So there is a 10-point differences almost with respect to the middlemost data, middlemost IQR range. Beautiful, right? And also the class A has almost near topper because the closest score is 100. Beautiful. Now let's proceed to the scatter plot. Here is just a scatter plot. What we are trying to understand to extract any meaningful patterns between score and our studies. Here we are trying to compare two different variables. Here also we are trying to compare two different variables, but one variable is categorical, which is A and class A and class B, and other variable is exam score. Whereas scatter plot is highly useful when we are comparing two numerical variables. One is hours studied and other is scores, where we can see a linear relationship with respect to the hours studied with respect to the scores scored. So that's how a scatter plot is directly useful rather than seeing the whole data. And here is just I'm giving just an one more variant of an histogram, where you can see that every time it is not so uniform like a curve, where you can see something like this, like a bell curve, but in reality you can see also something like this, where most of the times maybe the scores or something lies very less, and there are very rare probabilities when we increase it out. We will learn more about these type of distributions in the coming classes, maybe 2-3 episodes from here. But here you can see that there is something called skewness in this data. There is something called skewness in terms of this distribution. And there are huge outliers as we discover it or when we plot the box plots for this type of data sets. And so, what's the summary? We have seen that visualizations reveal shape, spread, and relationships in the data. And especially, we have seen the histograms and box plot tells us what is the distribution, and scatter plots shows us how we can compare two different variables and show the relationship between them. It can be a linear or non-linear relationship. For this episode 2, there is no homework because we are still learning the basics, and after a couple of episodes I'll try to start giving you a homework, especially from episode 6 onwards, which combines learnings of episode 1 to episode 6, because that's where we will try to step up in our better statistical learning. So far we are covering very basics, and I'm trying to explain you in a much more simpler ways and introduce you basic statistical terms. Now that's it for today's episode, and see you. The next couple of episodes are more important because here we are trying to learn about probability fundamentals and further explore about probability distributions, which are which is where the exact complications will arrive in terms of learning all these things. Beautiful, right? I'll stop it here. We'll catch up in the next week with episode 5, which is probability fundamentals.